So yeah, hi, thank you everyone for coming. Great turnout. Just as a quick introduction for those who don't know, myself and Stella both work for IO Associates, IT recruitment agency based in Bristol, but very involved in the local development community. Obviously, at the times we have at the moment, it's very difficult to, not possible to go in and do meetups as normal. So it's really great to see so there is still a sense of community and interaction with everyone, which I know is very, very important. So, Stella, would you want to quickly say something?
Yeah, so I've been with IO I'm running the meetups now for over a year. I usually know a lot of you from the Reading and London.net meetups, so nice to see some familiar faces. And I just place contract .NET developers and Azure developers, anything related to the kind of Microsoft stack. And that's my forte, basically. It's a bit of an introduction.
Cool. So yeah, I know you didn't come here to listen to us, but it's just a very brief introduction for those who don't know. If you do need it for anything, just give us a shout. But without further ado, we'll introduce Alex. I know throughout he did mention if you want to ask questions, just ask on the chat. I will stop my sharing now. I know Alex will share the screen, but yeah, have a good one. We'll catch you at the end.
All right. Thank you very much. All right, let me get my screen sharing set up here real quick. Make sure I do the right screen as well.
I'll make sure to mute myself as well, so you don't hear me drinking my Thatchers.
1 second here, and I will share the screen. I think it's this one, and this one, and this one. All right, can you see my main slide now? Well, hope you can.
Yep.
Okay, good, awesome. All right, well, welcome everyone. Thank you for joining in. This is an amazing turnout here of 120 plus people. So thank you very much for doing so. I'm going to talk about machine learning and ML.NET in particular today with you. And I hope you'll find this topic useful. If you have any questions to me during the talk, the chat is open. I'm more than willing to answer the ones that kind of make sense in the flow. And the rest I'm happy to answer at the end as well. But we're going to focus on ML.NET today. And to start off, just a brief introduction of who I am. I am a Microsoft MVP, and I am based out of Washington, D.C. on the east coast of the US. And as you can hear, I am not from the US. I am from Sweden from the beginning. And I know we have some Swedish people on the line, so a shout out to you guys. Thank you for joining. We had a discussion in the beginning here about Twitch, what Twitch is. And I just want to mention as well that I'm a Twitch affiliate. And Twitch is a company owned by Amazon that is really, really big on live streaming. And you may know it from gaming. So if you're a gamer, you may know it. If you're not a gamer like I am, you may not know it. And I discovered it when this whole epidemic started, because this is a way to connect with others and keep working on open source software and share some of the things that I learn with others. So I stream every Tuesday and Saturday, and I specifically stream about ML.NET. I only stream about that, actually. So if you want to tune into any of my streams where we work on open source software and teach ML.NET, you can do so, and you can follow me on that link right there. So please go ahead and do that. How many, it's hard to ask a question, I guess, on a virtual event here, but you may have joined the virtual ML.NET conference last week. We had a conference with about 500 people joining in last week on Friday and Saturday on the ML.NET topic specifically. And that's where we have these awesome shirts that we have produced. I love ML.NET. So if you want the shirt, I know the guy to fix your shirt. So definitely talk to me later and we can see if we can get that arranged. But basically we had a conference just on ML.NET and on that topic, which is really cool. And those videos are also up online on YouTube. So if you want to learn more about that after this talk, you can do so there. But what are we going to talk about today? Well, today we're going to tune into some machine learning concepts because I want to make sure we set a good foundation for everyone here to understand what machine learning is and what it's not and when you want to use it. After that, I do want to talk about the machine learning lifecycle because it's very important to understand what the steps are to build your model. Because we're going to talk about how you do it in C# today, but the steps are very similar, if not identical, if you do it in Python or in R or some other language that's more popular, I guess, or more mainstream for machine learning. After that, we're going to jump into ML.NET, and we're going to look at the open source library, which is the reason I think most of you joined today. And we're going to kind of see what we can do with that And we're going to end the slides pretty quickly, I think, and jump into some coding, because I want to actually write the machine learning model in C# with you live today, to see how it goes, and hopefully it will work. If we have time, and I don't think we'll have time, but if we have time, we'll also look at some Jupyter Notebooks, which is a tool to do some data exploration and data visualization for the machine learning lifecycle, which is important to do. And at the end, we'll wrap up some Q&A. I'll be around afterwards for questions as well. And you'll also be able to find me on Twitter or Twitch or wherever if you have any questions in regards to this. But before I jump into my slides, I do want to launch a poll here in Zoom. So let me find Zoom again and do that, because I want to see kind of what the audience is here. So if you don't mind, please go ahead and answer this question here on what do you identify yourself as here. All right, I'll give it a few more seconds here. We're almost everyone here. Perfect. All right, I think that's enough. Okay, I'm going to share a result here. So we have about 84% of the folks on the line today are software developers, which is awesome. That's exactly the audience I want to kind of turn to. And we have a couple of people that are data scientists and data analysts, and some management and other here as well. So thank you for that. The second one I want to ask you about here is if you have heard about MLNet before this talk. Interesting. This is a very interesting ratio here. So we have all right, good. I'll share a result here. So it sounds like about 62% has heard about MLNet before this talk, and about 38% has not, which is great. So we got some people that are familiar with it and some people that haven't used it yet. So we'll make sure to cover our bases here and get you all kind of introduced to it. Perfect. I think the last poll I wanted to ask is if you ever have worked with any Python equivalent libraries here, such as Scikit Learn, PyTorch, or TensorFlow. Also very interesting result here. Fascinating. So given the fact that we only had 2 people on the line today that said they were data scientists or kind of identified them as data scientists, we still have about 20% that said they have worked with either of these libraries, right? Pretty awesome. Which kind of falls in line to things that I want to talk about anyway, that you don't need to choose a bucket. You can still be a software developer, you can still be a data scientist or a machine learning engineer. It doesn't really matter too much. So thank you very much for answering those polls, guys. That's awesome. It gives me an idea of who we have on the line today. So the first thing I want to jump into is what is machine learning? And I'm going to keep it very brief here, but I want to kind of touch on some basic concept of machine learning, some terminology, and get people set to what we are going to do here. So we can then build a model in a live demo. So for me, machine learning in many ways is this.
Just tired debris from old Las Vegas, whose former fans have long dismissed allegiance to impressionists.
How many opportunities passed up and wasted because he's hell-bound to follow what he must? Pity the poor impressionist.
Doomed to live in abject failure.
So it's programming the unprogrammable. Some of you may have seen this video, some of you not. The video you're seeing right now was impressionist using something called deep fakes or deep learning to kind of put someone's face onto another person. So this person was just like you or me, filming a video and impersonating famous actors from the US and around the world. And a machine learning algorithm was locating his face on that video and then making sure you put something on top of that. And you've seen kind of videos like that with presidents like Obama or Trump as well. And that's something that's very scary and coming. But if you would program that using your C# some other language, that'd be very, very difficult, because you would have to have so many if loops and so many nested things and rules and regulations, stuff like that, that it would more or less be unprogrammable. And that's why we have machine learning, to generalize some things and to train our models, as we'll see later, to figure out what the answer is during different conditions. And machine learning kind of ties together with AI and deep learning in a kind of interesting way here. We're talking about machine learning today, mostly, but it generally falls under the AI umbrella. So when people talk about AI, machine learning is only one of those pillars. I would say that it's very disproportional, this image right here, because machine learning itself is just a small part of maybe AI umbrella, and you'll find things that are not machine learning related under the AI umbrella, such as linguistics and those kind of things as well. Deep learning, on the other hand, is a subset of machine learning. And deep learning is more or less machine learning on steroids. We take some of the things we have in machine learning and we apply it to a more refined way. And we'll find things like neural networks and other more complex things you may have heard of in deep learning. And in many cases, especially when it comes to business scenarios, you don't need to go to deep learning to get value for your business. You may just want to end up with machine learning and build classifiers to do simple things. So just keep that in mind as we go forward, as neural networks is not always required when we talk about machine learning. So we talk about machine learning, we always talk about a model. I'm sure you all heard the concept of a model and you heard about training. But what we really talk about here is we're taking data, and data is really the oil of machine learning. And we go through multiple iterations on that data so that we can fit our input with our output, so it makes sense. For example, a simple example of this is just house prices, super simple, but you have house predictions, so what something should cost. So you have an answer there, right? And you have multiple variables in between. For example, number of bedrooms, bathrooms, where it's located, those kind of things. So you're trying to tweak your model or your algorithm here that the input data, the variables, match the answer that you are trying to predict. And to put it more into like mathematical terms, I guess, is machine learning or a model is just a model, just a function in general. You have an answer, so y, that you're trying to predict, and you're feeding it with multiple variables, x1, x2, xn, into a function of your choosing. And that depends on what kind of algorithm you're going after here. And in your function, you're then fitting coefficients to match your data. And there are two important concepts when we talk about machine learning that people should be aware of, I think. And those are features and those are labels. Features are your columns in your data set. So those are things that change. For example, bedroom, bathrooms in a house. And label are what you're trying to predict, so the price. Label can also be if it's a fraudulent transaction or not. It can be if it's a tomato on a picture. It could be whatever is the answer, what you're trying to achieve. That's the label. You would normally hear label being thrown around a lot, so it's good to kind of just familiar yourself with that concept. Before we dive into more of the intrinsics here, I want to kind of display the different types of machine learning and what we really will be using here. There are multiple types of machine learning, but the three most common ones are supervised, unsupervised, and reinforcement learning. And I would say actually the two top ones are the most important ones, especially supervised learning. When we talk about supervised learning, we talk about things you may know, such as regression. So predicting the weather, predicting a price of a house, predicting the stock market, regression or time series forecasting. You can also see things like a spam filter, super easy, or supervised learning can also be things like predicting who's the person on a picture or an image. The distinction here between unsupervised learning is that you have labels. So when you train your model, you actually have data to train a model on, right? That has labels. So to give a simple example here, you may have 100 pictures of different pets. And 50 of them have a cat and some have a turtle or something else. But the key here is that you know what's in each picture. So you can tell your model that, hey, this is a cat, this is a turtle. Please figure out how to distinguish that. So when I feed you a picture that you don't know the answer to, you will tell me the answer, okay? When we talk about unsupervised learning, we don't know the labels, we don't know the answers. So we talk more about clustering or principal component analysis or anomaly detection. We just know the relationship of the data. So a good example in sales, for example, is that you have multiple clients and multiple potential campaigns you're pursuing. And you know that one client really responded well to one of your campaigns. But and you want to figure out, okay, what other clients would potentially would respond the same way to this campaign, right? What you can do then is take all those clients and apply something like clustering or PCA on top of those clients to kind of figure out how they're related. So you could project that in a 2D or 3D dimensional space. So you can say, okay, client A here is related to these other clients in its cluster, and client B is related to these clients over here. You don't know the difference. Like, you don't know, okay, this cluster here is because they're in the US and it's England. Like, clustering won't tell you that. You have to tell the model that itself, but it will show those relationships, and it'll be very useful in many scenarios. And anomaly detection is something that I think many has come across. It's just detecting anomalies, for example, in Bitcoin markets or in pressure valves in a factory or something like that. We don't necessarily know what's going on. We just know there's a change, and we want to react to that change. All right. So deep learning. I do want to touch on deep learning a little bit. I don't want to go too deep into it because I don't want to lose the majority of the crowd here. But my point from doing this is to introduce you to the concept and to make sure you understand that it's not as complicated as it may be perceived. It's actually a lot simpler when you look underneath the surface. And of course, it can be super complicated, and it can, spin off into these multiple different things. But the gist of it and the main thoughts is actually not that complicated. And I hope that after explaining these slides to you, that you will kind of see what it's all about. When you talk about deep learning or any of those concepts, a concept that always comes up and is discussed is neural networks, deep neural networks, or DNNs. Deep neural networks, what it really is this kind of schematic right here. You have something called neurons, so that's the green dots, and you have something called layers, and they're connected to each other, and they flow from left to right. You have something inputs coming in, and you have outputs. Inputs are going to be variables or your features that you know of your data, and the output is going to be the predicted label that you're predicting. So, for example, a simple example here is doing a fraud classifier. So we're trying to predict if a transaction on your account is fraudulent or not. Those kind of features will be the type of transaction, the amount that's being transferred, and maybe the GPS locations of the transfer itself. So let's say it's occurring right now in Sweden, but I am in the US. So that doesn't really seem appropriate, right? So that probably is a fraudulent transaction. So if you have those three variables at our disposal in our data, we can feed those variables into our network, and the network then will determine if it's fraudulent or not in the output layer. The secret sauce in a neural network is the things happening in between here in the hidden layer. So the two layers in between are called hidden layers. And in between these neurons, we have something called weights and biases that are being applied on each of these signals. And the weights and biases, in essence, is trying to determine how important a feature is over another. And you often, I think, heard that neural networks learn by themselves, right? And the way they learn is by adjusting these weights and biases by themselves to make sure that the input data maps the expected output. And when you train the model with data you know. So you feed in multiple rows of data where you know that this is fraudulent or you know it's not fraudulent, so the network can adjust its weight and biases accordingly. To look at that more in detail, if we zoom into a neuron, what the neuron is really doing is taking each input, so x1, x2, x3, and multiplying that with a random weight and adding it all together. And x1, to kind of go away from math here, because I don't want us to dive into math too much here, x1 could be the type of transaction, right? It could be the place we're doing it, or it could be the amount. So let's say we're transferring 200 pounds here. And the weight here is how important that feature is. And all the neuron is doing is adding those things up, adding a bias that's random, and then it's outputting that to the next neuron in the field here. And when the network learns, what it's doing is adjusting these W1, W2, W3 weights so that the output matches the expected result. All right. I can't see how many people are on Zoom still, so I hope I haven't lost everyone. I hope you're still there. But I think it's important to visualize this. At the core, deep learning is this, okay? It's additions. Okay, it is matrix additions, but it's additions. So it's good to just think of that a bit. Also, so just to kind of summarize the DNNs here and neural networks, there are about 6 concepts I think you should take away from this discussion as well. Neuron is just an abstraction of linear algebra. So when we talk about neurons network, it's just the conceptualization. It's just linear algebra. So it's that matrices, addition, and multiplication. When we train our model, we pass through tons of data that we know of, so we can adjust the weights and biases. Each time we pass through all that data, it's called an epoch. And we can then determine how many epochs we want to train the model with. Because the more epochs you have, the longer it takes, of course. And the more epochs you have, you may also see overfitting, which you don't want. But if you don't have enough epochs, so rounds in a network, you may not get a model that's accurate. I have a question from Ram here. I want to see, is neural networks algorithms only comes when we talk about deep learning? Yes, only when we talk about deep learning, we're going to talk about neural networks. If we talk about machine learning in general, as we'll see later, we actually don't touch that as much as we could. We touch more simple classifiers or other things, and we'll go into those in a bit here. So weights and biases, that's kind of what stores the knowledge, right? Well, what we learned is stored in weights and biases. Backpropagation is the process of learning, the learning process of the network. It's the way the network adjusts itself automatically to the input to make sure it's get a better accurate prediction. The loss function optimizers are very technical, but the loss function is something that's very important. For example, let's say we are doing a fraud prediction again, and we're passing through data that we know is non-fraudulent. And the algorithms say, okay, this is a fraudulent case. And we know it's not fraudulent. The loss function then, what that does is that it calculates how far away from my prediction was I. I was pretty far off, I guess, because we guessed the wrong thing. But based on how far away I was, it goes back and adjusts the weights and biases accordingly. If we were really far off, it's going to adjust it more than if we were very close. All right, so that was deep learning and that was machine learning. Let's go into something more practical now before we start coding our model from scratch here. I have a question from Deepak here as well. Machine learning is more about mathematics rather than coding, if I'm not wrong. Yes and no. So machine learning itself is more about mathematics, the underlying principle. It's a great question, I like it. But when you apply it, when you use it in the field, everything I told you right now is not important, okay? I'm telling you mostly so you understand some of the concepts, but when you use something like ML.NET, you don't need to really understand all these things because the library is abstracting it away from you, which is really, really awesome. And we'll get into that later. But when we build a model, there are some steps that we need to take, regardless if it's in Python or if it's in C# to get our model working. And I want to mention them because we're going to go through them when we solve this ourselves. The first one is pretty obvious. You want to identify your problem. What are you trying to solve? It may seem obvious here, but definitely take some time here to think about what you're trying to do. For example, like, are you trying to do a classification and predicting multiple classes? It could be a product review, for example. You're trying to say it's, I expect this product to have a review of 5 or 4. I expect this, for example, take a case where you have 1,000 pictures of different t-shirts and bags, and you're an e-commerce company, and you want to automatically label the category of the products based on the pictures. That's a multi-class classification issue. So it's important to kind of understand what kind of ML tasks you have at hand there. And there's about 5 of them, or 6 of them, I guess, that you want to think about. So kind of try to get that in the right bucket first, because after that, everything flows very nicely here. And ML.NET actually works on neural networks. And we'll get into that later. But it's a great point from Kiran here. He asked if ML.NET doesn't work with neural networks. From my understanding, you can run TF models for neural networks. Yes, so you can actually do deep learning in ML.NET as well. And you can also use existing deep learning models in ML.NET. So once you have identified your problem, what you want to do here is gather your data. And this is super, super important. I can't stress this enough here. If there's any steps you want to focus on, is gather your data. You want your data to be very, very broad. So you want to have as many different variables as possible. So it should be a lot of columns in essence. And it should also be a lot of rows because you want it to be representable of your situation. If you only have 100 rows of data, it's not going to work. You need a lot more data than that. And this is usually the most difficult step of all. You also want to make sure that your data is representative of the situation itself. So for example, if your data is skewed or biased or something like that, it's also going to affect the model who's going to learn from data and also be biased. So make sure that you are working hard on this step right here before you do anything else. Once you have your data, you want to split it. And you will usually want to split it in a test set and a training data set. The training set is going to be used to train your model on. So it's going to make sure we fit that model and all the coefficients so it works and makes accurate predictions. But a model is pretty useless if you don't know how good it is. So you want to store about 10 to 20% of your data as a test set or a validation set. So you can run that through afterwards on the model to see how good it was. And this is data the model has never seen before, so it doesn't really know what to respond. But what it predicts is going to be a really good indication of how good the model is from the start here. So once you have your data set split here in a train and test set, what you then want to do is transform your data to your butterfly or something. Now, what I mean with transformation here is also cleaning. You may hear like words like cleaning being thrown a lot when it comes to machine learning. So you want to transform your data in a sense that you remove any missing values, you transform textual values to numeric values, because a machine learning model can only work on numeric values. And in ML.NET, they need to be float vectors. You also want to normalize your data and those kind of things. And ML.NET is really good at helping you with this. We have tons of really good methods to just to do this with a one-liner, honestly. So a lot of things sounds complicated here, but actually when you look at the code, it's pretty simple and straightforward. But just know this is a step you need to do here. After that, you come into the machine learning part of this step, guys. We have to train our model. And this is actually the smallest one. This is like 2 lines of codes. One is to pick your algorithm, and the second one is called fit, which is going to fit your model based on the pipeline you created. So this is, when it comes to the coding part, this is very small, but this is actually where everything's executed and everything is done here. The takeaway I want from this step here is that don't be scared of this. You have to pick an algorithm in this step, but there's nothing, machine learning or data science is very iterative. You have to go back and forth a lot. There's a lot of experimentation happening. Even if, as an experienced data scientist, you don't know exactly which algorithm is going to work from scratch. You will try multiple. And in fact, there's even a tool that does it for you automatically, that tries multiple directly. So to see what fits your data best. So just pick one that you want to, try that, and if it doesn't work, adjust it and try something else, and then see if that works better. So the only thing I think that with data scientists, the more experience you get, the faster you will find a model that works for you. I think that's the only real key here, but definitely try a lot and see what works for you. Once we have trained a model, we want to evaluate it, right? So we want to run that test data through and make sure we have something like accuracy and other metrics to see how good our model is. Depending on what kind of ML task you're trying to do here, so classification, regression, you'll have different kind of metrics that you want to care about. Accuracy is normally one that is pretty important, but there are also others such as F1 score, precision recall, area under curve, a lot of terms that sound very foreign in general. A thing to think about here is just to not focus too much on accuracy all the time, but also take some time to read up on other metrics, especially if you're doing classification. Any other metric, almost any other metric, there are definitely exceptions, but a lot of metrics wants to be 1. If you get it close to 1 as possible, that's a good model. You don't want it to be 0. The only thing you really want to be 0 is like log loss entropy and stuff like that. But the majority of metrics wants to be 1. So that's the thing to keep in mind. After you have evaluated your model, then comes the fun part. And this is really where the library shines. You want to deploy it into production. And the cool thing with something like ML.NET is you can deploy it as an Azure function, an ASP.NET Core application, a Docker image, a desktop application. It's really your choice where you want to do it. Normally, when you work with Scikit Learn or something in Python, you would probably deploy it as a Docker container or something like that, which is great if you want to scale up. But you will need to have that kind of Flask API or something else to wrap your model around. And that normally works well, and it works pretty well with .NET Apps too, because you can call that container and that web service. But if you want to maybe do it completely offline on your phone or like a Blazor WebAssembly app on the front end, and you don't want any connectivity to the cloud or to any web service, it's really good to use ML.NET because you can really seamlessly integrate your application here. So that's really cool. All right. So I talked a lot. So let's quickly skim through ML.NET here, and then we're going to go do some coding. So normally, when we talk about machine learning, we hear R and Python being thrown around a lot. So TensorFlow, Scikit Learn, PyTorch, and those kind of libraries. And there's nothing wrong with those libraries. They're awesome libraries. They're fantastic and commonly used. But people always forget, I think, that we can also do it in C#, and it's been generally available for about 2 years and as an option for a lot of data science projects. ML.net is an open source software, so you can go ahead and contribute yourself on GitHub. They have a GitHub repo. If you have any issues, you can kind of put them there as well, and I'm sure the team will address them. And you can also open pull requests. It's cross-platform, so you can run it whatever platform you like, Windows, Linux, iOS, because it runs on .NET Core underneath the surface, which is awesome. And the fact that it runs on .NET Core is also really great because it's much faster than something like Scikit Learn. The memory footprint is much less, and it just executes and trains the models much faster. As I mentioned, you can deploy it as .NET. You can deploy it in whatever place or way .NET works, more or less. The only limitation, I think, right now is you can't really deploy it to an ARM processor. So if you want to deploy it to Xamarin, you may have some issues there, I think, because it can't run, I think, on an ARM processor. But I think that's something that's being worked on. You have really good support here for the model builder, and I see some things in the chat here. I think Louise is answering some questions. But the model builder is both a UI and a CLI tool that automatically builds a model for you. So if you want to get started, you can really use this tool. And the cool thing with that is it not only does it build the model for you, it also gets you the code that it used to create the model. So for example, I have like a data set from wherever. Maybe it's a data set on fraud, for example, and I don't know where to start. Well, what I can do is say, hey, I know this is binary classification because I know it's either fraud or not fraud, and I can just give it to the model builder. And the model builder will iterate automatically over tons and tons of algorithms, tons of parameters, and give me a model that works, and also give me the code that it used. So I can tweak the code if I want to change it a bit. So a really cool library, got a lot of traction, rightfully so. Another cool thing with the library is that since November, it has a .NET kernel for Jupyter Notebooks. So for those who are unaware what that is, Jupyter Notebook is kind of de facto standard for data science. This is where you run data exploration, data visualization for your models. So maybe you want to see relationships in your data. Maybe you want to visualize your metrics after you train your model. You can do so in Jupyter Notebook. And now we can actually run .NET in Notebook too, which is really, really awesome, honestly. I love it. And there's more and more work being done on that all the time as well. Ram asked a great question, actually. Does Databricks have an API for ML.NET? No, it does not. I would actually say directly here that anything, not that Databricks is Azure by any means here, but anything cloud-related like Azure has pretty poor support for ML.NET. And I'm advocating for that support. And if you want to advocate with me, please do so. One of the things I really want to advocate for here is support in Azure ML for ML.NET. And that would be really, really awesome if you can get that for sure. Also, finally, on this slide here, I know there was some talk in the chat about deep learning and neural networks. ML.NET supports deep learning to some extent. So you can do things like transfer learning in ML.NET. So you can take an existing deep neural network for image classification, for example, and you can retrain it on your own data. That's called transfer learning, and that's something that's heavily used in something like Keras or TensorFlow as well. And ML.NET under the surface uses TensorFlow as well. So it's not like there's a specific implementation of neural networks. It's actually just calling TensorFlow under the surface. And if you do it, you actually have to call in distributions of TensorFlow as well, which is really cool. I will say the support is pretty limited still. Like you can't really do much more than some computer vision tasks. And you can't really build your own networks. But a really cool thing that you can do is that you can use something called ONNX to import different models and use it for yourself. And ONNX stands for Open Neural Network Exchange, which is a standard I think both Microsoft and Google and Facebook has kind of agreed upon to export and import models from different frameworks into each other. So you can go into like the ONNX Zoo online, it's I think a GitHub repo, and you can pick a trained model that maybe does audio recognition or speech recognition, and you can import it into ML.NET and you can use it in your C# application like that. So there's definitely a lot of connectivity in place already, and I hope that this will be improved going forward. So that should be really fun, I think. I have a question from Kieran here. Does it mean I could use something like the VG16 inception model? Yeah, definitely. If that's something that is, well, I guess if that's a pre-trained model, you can do that. For transfer learning, there's a couple supported for like image classification. There's like ResNet from Microsoft. There's the Inception V3 from Google. And I think they've also added multiple other ones as well there. So you can definitely check that out. And Luis here is on the chat, and Luis is a content developer for Microsoft, and he's a co-organizer of this awesome conference last week. And I see that he's already answering questions, which is great. So thank you, Luis. And just the way we do this in Flow here, when we train a model, what we do here is we start on the top here. We collect and load our data. So usually that will be in a CSV file, that will be maybe in a SQL database or something else. So we will load our data into something called a data view. And based on that, we then create a pipeline on top of that. So we chain methods on top of each other. So we use method chaining in C# to append transformations. So we append the method to replace missing values. We append the method to transform the text to numeric. We append the method to say which training we want. And finally, we call fit on that chain. So that's like a pipeline chain. It's a concept. And after that, we evaluate the model and see how good it is. And then we iterate until we have something that we like. And then we save it down to a zip file. So the model is going to be a zip file at the end. And the zip file we can then take and load into whatever way you want to deploy it. For example, in an ASP core web API. And we can do our predictions on the fly here. And we'll see how we do that more in person here just shortly. Cool. And finally, before we go into coding here, Jupyter Notebook is really cool. Again, it has a direct kernel. It has a data frame API. So if you use the pandas data frames, it's a very similar API as well for a C# implementation of that. You can get started today if you want to by downloading something called Interact.io or the Anaconda distribution. And if you do so, you can get something like this slide here, where you have a cell of C# code, and you can visualize data. For example, in this case here, we are visualizing distribution of our images that we are trying to train the model on. So it's super useful to get an idea of the data. And I will leave that question, I think, from Phil actually to Luis or later about the tensor enabled in that, because I think that's a very in-depth question. So if you want to get started after this, I suggest that you go to the community samples. It's a GitHub page for this. It has tons of samples for you to get started, so you can kind of see how this is built. The MLNet docs is also awesome, and that's Luis who's answering your questions on the chat here. He's working on those, and they are fantastic. So definitely kind of read them as well. But I think the most important thing to do here when you want to get started with something like this is to try it. Just try it, get some hands-on experience. If you want data, go to something like Kaggle, which is a place you can find open data, and use the model builder to start with to get an idea of how the model looks like and how the process looks like. And again, from the model builder, you get the code as well. So you can review the code and you can see how it's trying to build a model, and you get the sense of the process. The important thing here is the steps are the same. The life cycle works. So if you understand the life cycle of creating a model, you will then understand what steps need to be taken to build your model, regardless of what that model is really. So definitely look at the life cycle. That really helped me at least to get some structure here. Cool. All right. So with that, let's start building our first model. I see that the time is 43, yeah? So we should be good here to go ahead and do this. So what I want to do right now is I want to go ahead and build a model for a very simple scenario. What we have here is data from Kaggle, and let me actually go to Kaggle real quick here so you know where the data is coming from. Kaggle.com. So Kaggle is this data science portal where you have competitions in data science and all kinds of things here. But it's also a place where you can find data sets. So if you have something you want to try or train, you can do it here. And a very like hello world data set for data science is the Titanic data set, which holds data on which passengers survived Titanic and which didn't. And it allows you to be able to predict your survival chance based on your own data, like your age and gender and those things here. So what I've done here is I've downloaded that data here, and we had those columns, and it's a very small set, so it'll be quick for us to train here, which is great. And in one column here, we have our label. Let me zoom in a bit actually. better, I think. We have our label, and this is the survived column. So survived is going to be either yes or no. So already from this, we know it's going to be binary classification because we only have two choices. It's binary, false or not false. We have passenger class, so 1, 2, 3, depending on if you're on the bottom of the boat or if you're on the top of the boat. We have name and gender and age and so forth here. So different parameters here that allows us to predict this final column. So we're trying to predict this, will we survive or not? And we already know a bit of this history, right? So we know that, you know, being in the third class is probably not a good thing because you were locked down and it was hard to get up. Being a female was probably also beneficial because there was more chivalry back then, or like females and children would go first on the boats. So probably if you're young or a female, you probably will have a likelier chance of surviving in this boat here. So we'll definitely test those theories as well when we do this model here. But if we do this, the first thing we always want to do is start Visual Studio. Number 1, get your thing set up and working here. And what we can do here is create a new project. So when you work with ML.NET here, let's see, what you want to do here is you want to create a console application, .NET Core console application. The library is in .NET Standard, so that's completely fine here. And we'll do it in C#, and what we'll do is we'll call this IO Titanic, for example. And we'll go ahead and create that, which will create a product. And if you have any questions during this coding, you can put them in the chat if you wanted to. I'm happy to bring them up here as well when we talk about this, and otherwise as well. Let's see if we can get Studio to work here. Awesome, I'll move it over here. All right, so super simple console application. We kind of know what this is already, and it should be good to go. The first thing I always do is I try to outline the steps we need to do here. So I want to outline the life cycle of creating a model, because that really helps me understanding what's the next step here. Otherwise, it's easy to get lost here. The first thing I always want to do here is load our data. The second thing we want to do was split our data. And then we want to transform our data. So that's cleaning, right? Or changing it from string to numeric values, those kind of things. And then we want to train our data, or train our model. Train our model. Then we want to evaluate our model to see how good it is. And then we want to save it to a zip file. So those are generally going to be the steps we're going to take here today to get our model working. But before we get started here, the first thing we want to do is install the dependency to ML.NET. So ML.NET is distributed as a NuGet package. Exactly, Ram. You almost beat me to it. I think I was a little bit faster. But yes, it is distributed as a NuGet package. And we can install it by just going to the NuGet prompt here, and it's called Microsoft.ml. You have lots of different options here. As you can see, there's tons of packages here. So it's nicely distributed based on what your needs are. And the main one is called Microsoft.ml. And then you have different ones depending on what you want to do. So for example, if you want to do like more deep learning image analytics, you probably need this image analytics one here. If you want to work with TensorFlow, you have this one right here, and so forth. And you will understand what you need once you actually want to use it. For our purposes, we only need this one right here, I think. So we'll go ahead and install that. And that should be pretty quick. We accept some license agreements, sign our life away, and hope for the best here. Awesome. So that's good. So how do we get started here? Where's our models, like or our methods to actually do these pipelines and train our models and those things? Well, they exist in something called ML context. And in anything you do, you want to start off by creating an ML context like this. On the ML context, if you go into that real quick here, let's look at the API instead actually. You'll see that we have a bunch of catalogs. And I'm just showing this so you can get a sense of what we have to talk about here. We have a catalog for different ML tasks here. So ML tasks is what we're trying to do. Binary classification is an ML task. We're trying to predict true or false. Multi-class classification is a second class because we want 3 or more classes. Regression, clustering, ranking, those are different things we can do with the library. And within each of these, you will find things like algorithms and evaluation methods and those kind of things. So they're grouped within their ML tasks. There are some more general things as well that you can use here apart from these. So for example, if you want to work with data, that should be in the data catalog here. So for example, if you want to load the data from a CSV file, that will be here. If you want to save our model, that will be here. If you want to do transformations on your data, that will be in transforms catalog. So once you kind of know where to look from, you will find it fairly easily. So I will add one thing here called seed, and I'll put it to 1. And we'll go back a bit later to talk about why we do that. But for now, just kind of think about the fact that you always want to add a seed when you train a model, and you can put it to 1 or whatever you want to. And we'll go back to that in a little bit here. So how do we load our data? Well, to load our data, we need to include it. And you can do this in multiple ways. You can have a reference directly to the data from here, or you can just include it in your solution. I generally like to include it in my solution, especially when writing these kind of programs. And I believe I have it under my C drive. I think I have a Titanic folder here somewhere. And if I don't, okay, there you go. All files. So simple CSV file. And to make this work properly, we also want to make sure we always copy it to output folder. So we have it in a bin folder, because that's where we will need to have it if we do a relative path, which we're going to do right now. Perfect. So as you saw, and I'll go ahead and close that file so we don't have any open processes messing with us. As you saw here, this is just a CSV file. Nothing complicated whatsoever. It just holds our data, and it has a header, and it has a data. So when we load our data, what we would do here is we will say, okay, the data. Very good, right? And we will go on the ML context, data catalog, and load from text file. That's exactly the method we need to use here if you want to load it from this CSV file here. So if you do that, we have multiple options, and it may be small for you to see here, but what we have here is the path to the data and different overloads. The first thing is, of course, the path. And we can either use relative paths or absolute paths. In our case, we're going to use a relative path because it's going to be copied to the output folder. It's going to be just next to the executable. So if you just say data.csv, you should be able to find it. Other things we need to do here is define if we have headers or not. So should we skip the first row when we read the data or not? In our case, yes, because we have headers. So we don't want the library to read that. And the last thing that's important here is a separator character. By default, I think the default is tab separated. So if you have tab separated files, you don't need to do anything here. But in our case, it's comma separated, CSV. So you want to do that. So notice one thing here. It's red. Why is it red? Well, it's red because it doesn't know what to do with its data. It needs to be a structured form. So we're missing a generic argument here of the schema type. So how does the data look like? So we need to find a schema before we can load it. And the way we do that is pretty similar to like entity framework. We just add a class here for the schema. In our case, it's going to be passenger, I think. Passenger spelling, which is going to hold all the property values. And I will open up this one real quick to see here. So we see here, we can capture all of these things you want to, but for time's sake, I'm going to keep it light here. So you want to capture survived, and maybe you also want to capture the gender and the age here. So let's just add those 3 columns here. And let's make this public real quick here, not that it matters. So what we'll do here is add a column for bool, survived. That's the label, right? Add another column for, come on, age. Please work with me, thank you. And finally, we'll add another column for the gender here, the sex. And you may notice here that I actually made age float, and it's not a float, it's an int, right? But anything in the library that you want to use as a numeric value in general should be a float. So just kind of keep in mind that as you walk through this, it's going to be the easiest way of doing it. So one thing we need to do as well here before we can use this is we need to define the index of these columns. So right now, the library doesn't know which property to populate with which column of the CSV file. And we can easily do that by something called load column and then index. So we know that survived is index 0, you look at the data, it's the first column. And then sex here is going to be 0, 1, 2, 3, and then 4. So we'll do, I think it's 3 here. Add the load column attribute here. And maybe like a space here, looks nicer. And a space here. And we'll do load column 4. Is the screen? Okay, good. Age was 4. Thank you for that. Let's see if that was right. 0, 1, 2, 3, 4, right? Yep. 4 and 3. Thank you on the talk today. That's really helpful. That saved us. And I hope that the screen is not frozen. Seems like people can see it. Thank you for that. Let me know otherwise. All right. So we have defined our schema. We're good to go. And I'm going to real quick just put that in order because I do not like unorder. And we'll go ahead and do that. So now we can say, okay, it's passenger. And it will be just happy now. So we have our data. So once we have our data loaded into memory here, and this is a lazy operation, it won't actually load into memory until we call fit. But in theory, what we have here is an iData view. And the iData view is going to hold things like operations or data. But the next thing, once we have our data, is splitting it into a test set and a train set. And what we do then is just test train split here. And again, we'll go back to the ML context. And we say data test train splits. So we have a nice method for this already available for us. And we pass in the data into it. And what we're going to get back here is an object that has test train, a property for the train data, and a property for the test data. So we will do that split for us automatically, which is really useful and really good. One thing to note here is that this has overloads. So by default here, this one is going to do a 10% split, so 90-10. So 10% is going to be done into a test set, and 90% is going to be into a training set. So you will train the model with most of your data. And with this, I want to go back to the seed 1 here. The reason why we do seed 1 here is because we want something called deterministic randomness. I think that's a term, or I just made it up. Not sure, but I use it a lot. If we put it to like this, what's going to happen is every time we run this again with F5, it's going to do a different split of my data. And if it does a different split of my data, it eventually also going to produce a different model. So you'll have different accuracy and you'll have different performance in general in your model, just because you reran the application. And that's not what you want. You want it to be consistent each time you rerun it. The only thing that should change is if you modify your data or if you modify how you create the model. So by doing seed 1 here, what we're saying is that please be random when you split, because you want to be random, but be random the same way each time, more or less. So that's kind of seed 1. So a long discussion on that, but just set it to 1 and you'll be good to go here. All right, so now we go into more of the data science stuff here. So what we want to create is a data pipeline. It's called the data pipeline, to be short. And we want to add transformations. And things we want to do here is we want to make sure we replace any missing values. So for example, I'm not sure if it's the case anymore, but we may have missing age values in the age column. So we want to make sure we set them to either the average or max or mean or something else there. Let's see, we have some questions in chat here. I don't think that different seed values will produce different models necessarily. They're going to be like equally good. It's just they're going to be consistent. That helps. There's also different ways of doing a split here. It's called cross-validation that doesn't do this kind of split. It actually falls into 5 or more different test sets here. But that's something we can discuss further if you have questions about that. So to create a data processing pipeline here, what you want to go to is transforms. And that's, again, the place you want to find these kind of things here. And the first thing we want to do here is replace any missing values. So if we look at the data set here for do that, what you'll see here is that we actually have a missing value here for age. So for Mr. Williams Henry Allen here, we don't have an age. So by some reason that was not recorded. And if we leave that blank, so it's going to really skew our model and mess it up. So we want to make sure we add appropriate value here instead. And there are many ways of doing this. So I'm going to show you the technique, not necessarily the best practice here. And Alec, when it comes to train set and test set, the reason we have two here is because you want to train the model on your train data and you want to test your model on your test data. So you want to measure how good it is on unseen data that the model has not looked at yet. But you want to spend most of your data to train it to get an accurate model. So I hope that makes sense. I'm happy to follow up with you afterwards otherwise. So when we do this, only thing we need to do here is we need to pass in the name of the column that we do, that we want to do this replacement for. And in our case, it's going to be H. So on our H column, we want to replace any missing values. We can use the default values if you want to, or we can also say, I want to do a specific replacement here. So let's do replacement mode, I think. Sorry, replacement mode. There it is. And let's see where it went. I need to spell correctly for IntelliSense to work. There we go. For example, we can either do the default value, which would be 0 for an interfloat. We could do a maximum. So we can take, what it would do then is we'll calculate the maximum value in this column and put that there, or the minimum or the mean. I generally prefer the mean. If you would do this appropriately, I guess data science wise, what you probably would do is you would see what kind of subgroup this person belongs to. So for example, is this a person in first class? Okay. What kind of gender is it? Okay, it's a male in first class. Okay, what's the average age of males in first class? Because that would probably give you much better indication of what the age would have been for this person. But for our case, we're just going to put an average of the whole column here. So once we had replaced missing values here, the second thing we want to do here is we want to append the next information here. So we're appending the next thing. The next thing we want to do here is we want to make sure we have the gender to the numeric value, because it can't work with male and female. It needs to be either a numeric value to work on. And what we're going to do here is we're going to use something called one-hot encoding to do so. And it sounds really complicated, but it's actually pretty simple. And let me write a code and I'll explain to you what it is. And we'll do that, passenger, and we'll do sex. So what this does here is it takes the sex column, which has male and female in it, and it creates binary columns for you. So it will create, in theory at least, I'm not sure this is the case, but in theory, it will create like is female and is male as columns. And it will put a 0 or a 1 into each column. So if there's a row with a male, it will, instead of having the gender column, it will have is male, is female, and it will be a 1 in this male column and a 0 in its female column. So that's a way to transform it into appropriate values here. So the last thing we want to do here before we're done with transformations is that we want to append we want to concatenate the feature vector. And what I mean when I say that is that we want to decide which ones of our properties or features do we want to use when we train our model. If you look at our data, we have tons of values, and we could definitely have added properties, all of those here, but maybe we don't want to use all of them when we train our model. So we need to decide which one should be included in our feature vector that we're going to train our model on. And also sounds kind of complicated, but it's actually pretty simple. What you want to do here is you want to go transform, concatenate. You want to name your feature vector, features, and then you want to just say which columns you want included in your model training here. In our case, it's going to be age, and it's going to be the sex here, and we'll be happy with those right now. The reason why I'm naming this features is because that's the default name of the features vector or feature column. You can name it something else if you wanted to, but if you do, you have to override a lot of other methods down the line here, and I would not do it if I were you. And we have a question here from Jinar. What happens when there's invalid value in the sex column? Good question. If you have that, what you would probably do before we do this in real life, you would check the values in the sex column first to make sure everything conforms to the accurate values. And what you would do then is figure something else out for it, honestly. For example, maybe you don't identify yourself as male or female. So we have 3 kind of values or 4 kind of values in this column, which is completely reasonable, right? In that case, you would use something else than one-hot encoding for this scenario. You would use maybe label encoding or something else here, categorical coding. So definitely a good question. Actually, what you would do is still use one-hot encoding. You would just have multiple more binary columns. So that's a really good question here. It would probably actually work really well. If you had a missing value in this one, though, it would not be so good. So you would need to replace those missing values with the default value. All right. So that was the data pipeline. It was a lot. Now we're going to go into the fun stuff here. So now we're going to actually build our model here. So train model. All we need to do now is say, actually, training pipeline first. We will take our data pipeline. We will append a trainer. And a trainer is the algorithm we want to use. So where we can find trainers is going to be under the ML task itself here. So in our case, it's binary classification, because it's either survived or not survived. And under that specific ML task here, we then have trainers catalog, where we'll find different algorithms. And there's different ones here. They sound very scary, like logistic regression or field-aware factorization machine, those kind of things. Again, there's documentation on this, which is really good, but I suggest you just try one. I usually use this one to start with because it's simple and doesn't have so many inputs, and it's a good one to get started with. So logistic regression, for example, what we need here is the label column. So remember again, the label column is the answer we're trying to predict. So in our case, that would be passenger, and it will be survived, I think, right? That's what we're trying to predict here. Let's see, is it one too many? Okay, good. So that's all it takes. By taking our data pipeline here, we are then appending a trainer, and we're telling the algorithm which column we're trying to predict. So it's going to optimize the data for that specific column. Once we have that, we are really good at just doing this, train model. And this is going to be the model we want. And what we do is just take a training pipeline, and we call the magic method fit. And this is where all the work is happening here. And the thing we need to pass in here is our training data. And the train data we have above after our split. And like that, it's going to get our model. And Ben has a great question here about, or a comment here about normalizing the data. Exactly. We definitely would normalize the data. So there's a way also to append the normalization here from mean, max, or binning, different things here. And that's something you probably would also do here if you were building a production-ready model here as well. That's a great comment, Ben. So we have RAM, great question. Plotting support, we have, if you have Jupyter notebooks, you can do plotting as well in Plotly or any other open source tools. And there's some really cool contributions happening as well for evaluation metrics for confusion matrices. And we can look at that later as well. All right, so just to wrap this up here, when we have a trained model here, what you want to do is evaluate your model. And to evaluate your model, you do two things. First of all, you want to get predictions on your test data. And to do that, you take your trained model, you call transform, you pass in your test set, that will give you predictions. The predictions is more or less saying, okay, here's my test data. So these are passengers you haven't seen before. Please tell me what you think. Will this person survive or not? So we get those predictions here. We can then pass those predictions into an evaluation method for this specific ML task. And the ML task will tell us how good those predictions were. Like, oh, you were pretty good, but actually no, or you were really good. So what we'll end up having is metrics here. And let's see, that should be ML context, binary classifier, evaluate, live coding later in the day here, and name of passenger. So we still need the same kind of label column here again. And then I believe you need to pass in the predictions here. Maybe it's the other way around. Let's see. Yes, the other way around here. So we'll pass in the predictions first, and then we'll pass in the column here. So that will give us some metrics. So this will tell us if how good the model is in general, accuracy, those kind of things. So once we have that, what we finally do is just save the model, and that will also be on the ML context. It'll be model, save, and what you'll do here is pass in the trained model, and you'll pass in the schema, and I think that's going to be on your data sets. So you can do train data schema, I think. And then finally, you want to pass in the name of the file here. So the name of the model itself. So we call it just ml_model.zip here, because it can be a zip file. Wow, okay. So we did that in 20 minutes. It's a bit of code, but not too bad. It's like 36 lines. And again, you can automate all these things if you want to. So let's see if this actually runs here. We may have messed something up here. So let's try this and see if it breaks or not. And all I need to do is just hit F5 or click run here, and we'll see if our model is actually training or not. So it's building. Let's see if this works. If it doesn't work, sorry. If it works, that's awesome. All right, so we hit the fit method here. So this is where all the magic's going to happen. Everything else was lazy loaded, so that's been pretty fast. This is where it's going to take a little bit longer, but this is a very small set, so if it doesn't explode, it'll be quick. So it went really fast because it's a really small data set. We'll get our predictions, get our metrics. We can look here at our metrics, and maybe it's small here, but I'll pin this. Actually, let's do this anyway. Hopefully you can see here. But you can see here, from this very rudimentary model, we have an accuracy of 83%. So 0.83 is 83%. For a classifier, accuracy can be misleading, but usually you want a good accuracy, of course. The thing you want to look at here is the F1 score, which is the harmonic mean between precision and recall. And the F1 score here is 0.74, which is pretty good, honestly, because you want it to be as close to 1 as possible, and 74 is not bad. I can definitely take that given this limited exercise. We can also get things like confusion matrix here, and that's something I can happily discuss with you afterwards. But a confusion matrix more or less tells us how confused the model is, of course. So it will tell us, okay, how many of our predicted values match up with our accurate, our ground truth, so to say. So you want everything on the diagonal, because that means that everything that you predicted being survived was actually survived, and anything you predicted not surviving was actually surviving. If you have anything that's not on the diagonal, what you have is false positives or false negatives, and you don't want them if you can limit them if possible. Cool. So with that, I could do this in a lot faster way than this. For something like simple as a binary classifier, I could just pass this data into the model builder, either through the UI or through the CLI, and I can get the same or even better model probably in like 10 seconds. But I really like writing the code because this gives you an idea of the process you have to do here. And for more advanced tasks, you may want to get into the coding as well. And I honestly really enjoy writing the code and doing it myself. But that's definitely like it depends on what you like and what you prefer yourself, I think. So I have a question here from Alec. I do not know what an ARIMA algorithm is, so I'm sorry I can't answer that question. That's a good question though. Maybe Louise or someone else on the line could answer that question if you know it. But with that, actually, that was everything I want to show you. I have some more demos on Jupyter Notebook that I'm happy to kind of show you now or later. But I want to open up for any questions you may have in the chat, or if you want to unmute yourself and ask those, please do so.
Hi, Mitch here. I'm just wondering, earlier you mentioned that you can only really use numerical values. One of the data sets I'm working with relies heavily on perceptual image hashing, which is essentially a 64-bit hash value.
Okay.
Which comes out as kind of 64 zeros and ones.
Yeah.
And I'm just wondering if what kind of transformation I would have to do on that to make it useful in machine learning.
Sure. Yeah, so everything in machine learning in general, whether that's Scikit Learn or MLNet or TensorFlow, uses numbers. That doesn't mean that everything needs to be numbers from the start. It just means that you transform it to numbers. And it sounds like your use case, you're doing image classification. Is that correct?
It's actually to do with determining a sender of a document. So
okay.
part of that process uses the sort of top 28% of the document, a rendered preview of that, and provides the image hashing. So then that is then compared through Hamming distances to historical documents.
Yeah. If it's text, you can use different text transformations. You can do featureized text and do n-grams and chargrams. If you have text, and that will automatically be transformed to numeric values for you in the background. If it's something like an image, I'm not really fully in the loop of this one here, but if it's an image, what you will do then is have each pixel value in each of the channels represent a feature. So that will be a feature by itself. So for example, if it's an image and it's grayscale, it would be like 0 to 255 for each pixel value. And you can feed that into a convolutional neural network for image specification. So happy to follow up with you afterwards or on Twitter or something else on this question if you want to. Awesome. Do we have any other questions? Do you want me to read the questions here in the chat?
I had a quick question, and I think the answer is going to be no. But I was working on a project at one point with essentially I was taking images and I was trying to see whether I could upscale them using GANs, so generative adversarial neural networks. So that's, you know, two neural networks competing against each other, one as a discriminator, one as a generator. Is there any way that you could do anything like that with ML.NET or?
Great question. I haven't got too much exposure with GANs, honestly, but if it's a deep, it depends on if you want to train a GAN or do you want to use a GAN?
I'd like to train it.
Okay.
Either or. I mean, if I could use it, then that's a positive in itself.
Yeah. You can't train it for sure. That's not going to be something that's happening right now, at least. You can definitely use it, I think, as long as you export that model to an ONNX format. I haven't tried it myself, so I can't promise that, but there's an ONNX format that you can kind of export it to, and then you can import it in ML.NET and use it in ML.NET. And there's tons of really good examples on the community repo on how to do that as well.
Fantastic. Thank you.
You're welcome. All right, I think Jason had a question here. I'm assuming now that we have created this ML model zipped, we can pull this back into another project. Yes, exactly. So what we can do is really simple. Well, not really simple, I guess, but what we can do is just, if I can get the Zoom thing go away here. If you can, what you want to do here is the same thing. You would create an ML context in whatever you want to use this, and you can go on the model, and you can then do load model. And then you must provide where this model is coming from, your zip file. You have to provide also the schema for the input and output. So you need to provide the same kind of passenger schema so it knows what the data is looking like. And you also need to provide a schema for the output. So I think usually it's like 2 columns, like the score, so like how certain it is that it's the accurate prediction, and also the prediction itself. Those are 2 general things you want. And depending if you deploy it to an ASP.NET Core application or not, you also want to do things like a prediction engine pool, because it's not thread safe by itself, but you can register this really simply in the startup class. So I hope that's helpful. Let's see here. We have a question from Dushyant. Are you or anyone in the group able to suggest a starting point to learn neural networks deep learning, ideally open source, with the aim of fraud detection in financial software industry? Great question. Where would I start? I think if you want to like learn real deep learning stuff like neural networks and not necessarily focus on ML.NET first, that would probably be a good start. And there's some really good books out there. I don't have them. No, I don't have them here. But one is by Francois Cholet, I think, who is the founder of Keras, which is the Python API on top of TensorFlow. And he written a book that is pretty, of course, Python and Keras, but it also touches a lot on deep learning and what it really is and how you think about those things. There's also another really good one that touches TensorFlow. So I would recommend having one of those books to start off with, and then transition from there into a use case, whether that's going to be with ML.NET or not. There's also really good community samples on deep learning, and I would recommend you look at that, I think.
Hello, Alex.
How's it going?
Hi, quick question. What do you actually do in your Twitch streams? I know you've been mentioning that you do a couple of Twitch streams a week. And
yeah.
So I was just trying to understand what happens in them.
I have fun.
Oh,
No, great question. So on Saturdays, what I do is on Saturdays I work on an open source project that I created a few weeks ago, together with actually people on this line and others. And it's called MLOps.net. So right now, like when you create machine learning models, it's very experimental. But once you figure out a model, you need to store it somewhere, and you need to store the metrics, and you need to have that traction or audit between the model, the data was used, the code, and those sort of things. That's kind of like DevOps, right? You want to deploy to production. And it's called MLOps for machine learning, and it's really poorly supported when it comes to ML.NET. You can do all this really cool stuff in Azure Machine Learning, but only if you have a Python model. So what we're doing right now is building an open source tool instead, so we can use that in GitHub Actions or whatever you want to. So on Tuesdays, I work on this with a couple of folks for right now, Luis being one that you have heard on the chat here. And on Saturdays, what I do is I do a joint stream with a gentleman named Ravi from India. And he wants to learn machine learning and ML.NET, so he's a beginner. So every week we do an episode where he starts building a model, or we kind of walk him through different parts of the process and teach him more and more about that concept.
Okay, interestingly, my name is Ravi as well, and I want to be on that list. So, is that something I can join you for this Saturday?
Absolutely. Yeah, you can join whenever you want to. So I know that many people don't have a Twitch account because if you don't, not a gamer, you don't have it, but you can create a Twitch account, it's free. And you can hit the follow button here, and then you'll get a notification on your phone or email when I'm live. But in general, it's on Saturdays, it's 9:30 a.m. Eastern time. And on Tuesday, it's like 10 a.m., I think, Eastern time. So yeah, definitely just follow me and you'll get notified and join whatever. It's completely free, and I would love to have you on the stream.
Thank you, Alex.
You're welcome. All right. If there's any question, please do unmute yourself, I think, because there's a lot of questions in the chat, and I'm not sure where I am.
Hello.
How's it going?
May I raise my question?
Absolutely.
Okay. Well, my question is the following: how does ML.NET stands compared to Python libraries in terms of learning curve, efficiency, and lines of code? Okay. What's the trade-off between one and the other?
Yeah. So I started with ML.NET about 2 years ago, and I always been interested in machine learning, but never really done it. Played around with Python a bit, but never really. So when I started, I did both actually. I did like build the model in C#, and then I built in Scikit Learn to understand both. There are definitely pros and cons, but one pro I really like here is it really helps you and guides you. Like there are very sensible defaults in ML.NET. So you don't need to always set every override. It will like figure it out for you, and it won't break. Like I was building the same model, for example, in Scikit Learn and in ML.NET. And in Scikit Learn exploded, and I had memory out exceptions, and I had like poor model. And in ML.NET, it just understood what I was doing, and it was nice to me. When it comes to performance, it's much faster. It's runs on .NET Core and C++, so it's a lot faster to train. And there's even like, you can follow Hyping on Twitter. He does a lot of TensorFlow things, and he's writing TensorFlow bindings for C#. And he's proven that the TensorFlow bindings in C# is a lot faster than Keras bindings in Python. And that's like an example with both of them. When it comes to the learning curve, that's a good question. They're pretty similar, but I would say it's simpler with ML.NET just because you have the AutoML ability to kind of automatically create your model and see how the code looks like. So you don't really have the same kind of equivalent, I would say, in Python.
Just following up from, sorry, bad timing there. I just wanted to quickly jump in and ask, because you were talking about performance. One of the things that I tend to do is train on my GPUs. Does ML.NET enable you to do any sort of training on the GPU through CUDA or anything like that?
Great question. We actually got that during the workshop and the conference last week. And I believe Bree answered this, and I think Bree is actually on the line today as well, so I'm going to call you out. But I think the answer is no. Right now, it's not supported on the GPU, but I think that's being worked on. So right now, everything is on CPU, I think. But when you do the model builder, and I'm sorry I can't show you right now because I don't have the latest installed here, but there's now, since just a while back, you can fan out your training to Azure Machine Learning. So, for example, you can do image classification and train a neural network for that automatically. But that's very, very heavy if you don't use the GPU, right? So its CPU is going to kill your computer. When I did it locally, my computer dies because it just gets too hot. But you can use cluster in Azure Machine Learning to kind of fan that out directly from Visual Studio, so you don't need to do that on your computer by itself. So that's just a workaround, I guess, right now for that scenario.
I suppose if you're using neural networks, you could always train them. Yeah, just train them classically and then run it through as well.
Exactly, and I think that's definitely going to be support for this going forward, though. It's just right now there's no support for it.
It's good to know that they're thinking about it, and that's great.
Yeah. Let's see, actually, Bree, are you on the line? Do you want to unmute yourself? Maybe she's not. She may have left. That's fine.
Hi. Just one more quick question. Do you have any tips on multi-tenancy? So I know in the use case that I'm looking at, it's likely going to need a training set per tenant because the kind of input data is going to be very, very different.
Are you training a model per tenant? Are you training a model like on the fly per tenant, or are you training a model and then like serving it per tenant?
I think probably we'd have to eventually get to sort of on the fly training or retraining maybe every 24 hours or once a week per tenant, that sort of thing.
That's a really interesting question, because I've actually seen a lot of discussion on the same topic on Stack Overflow. So I would recommend you kind of go in, join that conversation a bit. My limited understanding of this scenario, because I haven't done it too much myself, is that you can, if you deploy your model to like an ASP.NET Core application, the way you can deploy it is actually on like a blob storage in Azure or from a URI. So you can serve from URI. And by doing that, you can also say, please poll this location every 10 seconds or whatever, if there's a new model or a new version. So you, in theory, could then retrain your model on the fly, and it will automatically load that back into memory once it's served without taking down your application. Not sure that helps with your question, but that's just something I want to put in there.
No, I think that's a really good point. Thank you.
You're welcome. Awesome. Any other questions here? Great. Well, if you have any other questions otherwise, always follow me on Twitch, Twitter, or LinkedIn, and I'm happy to kind of answer them as well. And if you, okay, good question here. How do you get a t-shirt? I'm going to put the person in this Slack here for Twitter that you can stalk. Sorry, John, if you're on the call. We can talk to John about this. So John is one of the co-organizers for the conference, and he is the one who made these shirts for us. And I think what he's going to do is create like a group order on Custom Ink to do this. So definitely follow him on Twitter if you want the chart, and I'm sure he's going to post one there as well. And the conference link, sure, I'll post that as well. So it's virtualml.net. We're going to hopefully do a hackathon soon on that. That's something we want to do. So if you are interested in doing that, you should definitely do that. You can follow the Twitter handle for virtualml.net to get updated. I'm posting a lot of information here, but just in case you're interested. And finally, if you want to watch any of the talks from the amazing speakers, you can do so as well. Here's the YouTube channel, and these were uploaded end of last week. So if you want to kind of have a more specific topic you have in mind, you can kind of watch these amazing speakers and follow them as well if you're interested. Cool.
Hi, everyone. Thanks very much, Alex, for that. Really, really good talk and lots of great questions from everyone. And thanks for attending. It's obviously our first meetup on Zoom, which was good. So thanks, everyone. And obviously, as Alex said, if anyone has any questions that you didn't get the chance to answer or ask tonight, and you think of them, today or tomorrow, drop him a message on LinkedIn or Twitter. We have also recorded this event, and we will be processing that, and hopefully it'll be with you by the end of the week as well, if there's anything you want to catch up on. But yeah, thanks very much, everyone. And Mickey, did you want to say any final words?
Yeah, I also just want to echo what Stella said. Thank you very much, Alex. Thanks for everyone for being. It was really interactive, and those are really good questions. There will be a survey as well, because obviously we want to try and make sure we keep improving these virtual meetups. If you want to answer that afterwards, and what we can do as well when we send out the video, we'll send out the links as well that Alex has put on the chat, so people can have them as well. So if Alex can send them across to us. But, yeah, cool. Have a lovely evening. Obviously, I don't know where everyone is in the world, so it might not be evening. But yeah, thank you again. And we do have another virtual meetup planned for the 9th of July. I believe that confirmed now, Stella?
Yeah, we have confirmed that. That'll be on the 9th of July, most likely at the same time, 7 p.m. We're welcoming Scott Hanselman. So if you keep an eye out on our LinkedIn page, and feel free to connect with myself and Mickey, and we'll be releasing details of that soon.
Awesome.
Cool. Cheers, Alex. That was amazing. Really appreciate it.
Thanks, Alex. It was amazing. Thanks very much.
Thank you, everyone. Thank you for tuning in.
Thank you.
Thank
Take
you.
care.
All right, thank you.
Thank you. Bye.
You